Concept 3, finding the probability of dependent events. All right, so finding dependent events is very similar to independent events. All right, we're still multiplying the two probabilities together. The only difference is we have to do a little bit more calculation, a little more thinking to find what that second probability is, right? Because it changes based on the outcome of that first event. All right. So in our first question, let's jump right in. What is the probability of pulling two cards at random from a deck of cards and having them both be an ace, king, queen, or jack? Okay. Well, our job first is to figure out what our first event probability is. So our sample size, all right, standard deck of cards is going to be 52. All right. And from that, we can pull, and it doesn't matter about the suit, we can pull an ace, king, queen, or jack. So we've got 4 options in each suit. So we've got 16 possible outcomes. Okay? And we can simplify that, but I'm going to leave it the way it is for now. Okay? And then what we're going to do is look at what changes. Okay? Since we're only interested in our event, both of our events happening, we're not going to worry about what would happen if we didn't pick an ace, king, queen, or jack on our first try. We're just going to be looking at, okay, we've picked an ace, king, or queen, or jack. Now, what is the probability of our second event? Okay. Well, first of all, we have one less ace, king, queen, or jack. So now we're down to 15. All right. But we also have one less card in the deck. So we're down to 51. Okay? And this is why I say there's usually a bit more math to do this multiplication, because our denominators are going to be slightly different, right? Our numerators are going to be slightly different. So when we are doing the calculation, and I'll pull out calculator, it's going to be a little more messy. So let's go and do 16 times 15. We get 240. Okay. 240. All right. That seems big. That seems like we're going to have a lot of possibilities. Okay. Clear. And then we got 52 times 51. Oh, all right. That's a lot of sample set, right? That's a lot of options. So 2652. 2652. All right, and now let's see. We're going to want to simplify that. So cut them both in half. We'd have 120. Oh boy. 120 and 2652 divided by 2. 13, 26, oh, we can cut them in half again, 60, and what's that going to be, 650, 663, 663, all right, let me make sure, divided by 2, yeah, 60, okay, so now both of those are divisible by 3, so divide by 3, 221, so now we got 20 out of 221, and I think that's it. I might be wrong, but I think that's it. I think that's as simplified as we can have it. Okay, so that would be our answer, 20 out of 221. All right, now we did all the simplifying, okay, and I did that partly to show you really want to simplify early. Okay, it would have been really easy for me to pull out a 4, right, from each of these and get 4 out of 13, and that would have saved me a couple steps here. All right, so try and simplify before you multiply. All right, it'll make your job a little bit easier. Okay, so now let's look at another one. All right, kind of same idea, but now we don't really have the same event. Right, up here we were looking for pulling those same cards. Okay, but now we're looking at two events that are still dependent, right? They're still connected, but they're not the same. Okay, So we're looking at this pile of M&Ms, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 M&Ms. So that's our sample size. And the first thing we're doing is we're looking at the probability of me taking an M&M and having it be red. Okay, so we've got 3 red M&Ms, so that's going to be 3 out of 16. Okay, let's say I take this guy. That guy's gone. All right, and then we're looking for you taking an M&M at random and having it be red or green. Okay, so now we're going to multiply it, and now we've got 1, 2, 3, 4, 5 red or green M&Ms left. And I know I've got 1 less M&M, so 5 out of 15, or we've got 3 out of 16 times 1 out of 3. Okay, that actually is pretty easy. 3's cancel, and I'm left with 1/16 as my probabilities of that happening. Okay, so look for ways to simplify, cross-multiply. It'll save you a lot of time. Okay, and when we're looking at dependent events, make sure that you are adjusting for that first event. Okay, that first event where we're always saying, okay, that first event happened. Now, what's the new situation?